we'll continue with the continuation of the statistics revision class. So in the last class, on what topic the questions were discussed? Yes? Yes, it was on theoretical distribution. So I hope the blueprint is visible to you. Okay, so our discussion was based on theoretical distribution. One second. Okay. So it was based on theoretical distribution. Okay. Yes. And as I told you, altogether, the total weightage for this chapter will be 23 marks. When is the stats exam? When is the stats exam? 5th March. Yes. Okay. So we'll continue with the next concept, that is statistical inference. Again, the weightage for this chapter is 23 marks. So let us go back to our model paper. Okay, sorry, there's some problem. One second. Yes. Sorry for that delay. I hope all are there. Yesterday, accounts hints and theory PDF. Okay. Okay, we were discussing question number 32, 31 and 32 from the model paper. And I told you that these two questions will be from theoretical distribution for 5 marks. And remember, dear students, I had told you that for question number 31 and 32, it could be any sum from binomial, Poisson, and hypergeometric distribution. It could be to find the probabilities or it could be to fit the distribution, okay, to find the theoretical frequencies or the expected frequencies. Okay. Now let us see question number 33 and question number 34. Okay, is it clear? Bhavana? Question number 33 and 34. Okay. So question number 33 and 34 is from statistical inference. Okay, is from statistical inference. Now, how many test statistics have you studied in this chapter? How many test statistics? Just to recall, even in the last class we had discussed. Okay, 10. So we have large sample test. We have large sample test. We have small sample test. And then we have chi-square test. Okay. Now, what are the 4 applications of large sample test? Can you tell me the 4 applications of large sample test? There are 4 test statistics that comes under large sample test. What are the 4 application? Yes, to test for the significance of mean, that is single mean. Okay. Then equality of means. Equality of means. Then we have, this question is important for 2 marks. Application of large sample test. Okay. Then test for single mean, equality of means, and then test for single proportion or significance of proportion, population proportion, yes. And then we have test for equality of proportions. Equality of proportions, okay. What about small sample test? How many applications? Small sample test. 3 application. And what is the distribution that we consider over there? What distribution is assumed whenever the sample size is small? Yes, it is t-test or t-distribution. 3 applications. So test for single mean when the sample size is small. Test for equality of means. For small sample. That is if n1 plus n2 is less than 30. Okay. And then we have, yes. What is the third application? Yes, dear students. What is the third application? It is paired t-test. Okay, paired t-test. Okay, under chi-square. How many applications of chi-square test? 3 application. That is test for variance. Then we have independence of attributes. Yes, independence of attributes and goodness of fit. Okay. So altogether we have 10 test statistics. So out of these 10, any three test statistics will be asked. Okay, any three test statistics. That is, we have two questions under section C. That is question number 33 and 34. 33 and 34. And then under Roman number 7, we have one question. That is question number 38. Okay, question number 38. So all together, you can expect three 5-mark question from the inference chapter. Okay. So let us see what are the formulas or the test statistics that is available to test for the mean or the average value. Mean or the average value. Just recall. Okay. So if it is a large sample, that is if n is greater than 30, greater than or equal to 30, we have for single mean Z, large sample. So x bar minus mu naught by sigma or S by root n. So which follows standard normal distribution. If the sample size is less than 30, we have T distribution, that is x bar minus mu naught by S by root n minus 1, which follows T with n minus 1 degrees of freedom. Just recall the formulas. If two means are given, if suppose we are testing for equality of means, then we have Z is equal to, if the sample size is large, x bar 1 minus x bar 2 divided by a root of sigma 1 square by n1 plus sigma 2 square by n2. And in case of small sample test, we have x bar 1 minus x bar 2 divided by root of combined variance SC square by 1 by n1 plus 1 by n2, which follows T with n1 plus n2 minus 2 degrees of freedom, where SC square is a combined variance and it is n1 s1 square plus n2 s2 square by n1 plus n2 minus 2 degrees of, okay, minus 2, which is a degrees of freedom, n1 plus n2 minus 2. Okay, then we have one more formula to test for the mean, that is paired t-test. When the observations are paired or correlated, we go for paired t-test. So, and the formula will be d bar by sd by root n minus 1, which follows t with n minus 1 degrees of freedom. D is a deviation or the difference between the values. What is D? How do we find D? When paired observations are given? Do you remember? Yes? Yes, it is x minus y or x1 minus x2. D bar will be the mean for the difference, that is summation d by n. And SD will be the standard deviation for the difference. So that is summation d square by n minus sum of d by n whole square. Okay. So these are our formulas, 5 sets of test statistics, which is used to test for the mean or the average value. Okay. Then we have test for variance. Variance, that is chi-square test. And the formula is ns square by sigma naught square, which follows chi-square with n minus 1 degrees of freedom. Okay, n minus 1 degrees of freedom. Then we have test for proportion. Okay, test for proportion. Just recall all the test statistics. When the sample size is large, we have test for proportion, that is P minus P naught divided by a root of P naught Q naught by N. When two sets of observations are given, we have P1 minus P2 divided by a root of P hat Q hat 1 by N1 plus 1 by N2, which follows standard normal distribution, where P hat will be either N1 P1 plus N2 P2 by N1 plus N2, or it can be x1 plus x2 by n1 plus n2. And what is q hat? How do we find q hat? How do we find q hat? That is 1 minus p. Okay. So that is 1 minus p hat. Okay. So these are the two formulas that is available to test for the proportion value, single set and when two sets of observations are given. Then we have test for goodness of it. That is chi-square is equal to summation y minus ei whole square divided by ei. And this follows chi-square with n minus c degrees of freedom. Then we have independence of attributes, where the data will be presented in a 2 by 2 contingency table. And we have the formulas as capital N into AD minus BC whole square divided by the product of the row totals and the column totals. That is A plus B, C plus D, A plus C, and B plus D. And what is the degrees of freedom, dear students? Very important question for 1 mark. What is the degrees of freedom to test for independence of attributes? Yes. Independence of attributes. It is 1 degrees of freedom. Very good. 1 degrees of freedom. Very important question for 1 mark. Okay. Now, there is a condition. There are few conditions for the cell frequencies. That is EIs. Can you tell me what is the condition? Again, an important question. What is the condition for the expected cell frequencies? There are few conditions. Even while testing goodness of it, we have few conditions for expected frequencies or theoretical frequencies. What is the condition? How the frequencies should be? Observation should be? Yes? What is the condition? The expected cell frequencies should be? Yes, total frequency N should be large, right? Then, how should be the value of EI? The expected cell frequencies. EI should be 5 or more. 5 or more than 5. Okay. EI should be 5 or more than 5. So, these are the 10 sets of formulas that can be applied for any given sum. So, depending on the availability of the data, we choose the test statistics. Depending on the sample size, we decide whether it is large sample test or small sample test. So, let us solve the sums. Shall we solve the sums? Okay, now you have to identify. Okay, so question number 33 and 34. As I told you, under section C, you have to answer okay, under section C, you have to answer any four. The first question is from index number chapter. Second question is from interpolation, extrapolation. The third, question number 31 and 32 is from theoretical distribution. 33 and 34 will be from statistical inference. Okay. So now we are discussing question number 33 and 34. Now just see the question. I hope the question is visible. Is it clear to you, students? Yes. Okay. So among 400 randomly selected persons of a city, 280 like ice cream. Okay, 280 like ice creams. Test at 1% significance that 50% of the people in that city like ice cream. It's blur. Okay. Now is it clear? Yes, Nishal? Is the question clear? Yes, it's better. Okay. I'll read the question. Among 400 randomly selected persons of a city, 280 like ice cream. Test at 1% level of significance that 50% of the people in that city like ice cream. Now, dear students, now for those students who find these concepts difficult, that is inference difficult to identify the test statistic, just read the question once. If there are words like mean or average, understand that it is mean test. Okay? If there are words like mean or average, you are testing for the mean value or the average value. Now, along with mean, the standard deviation or variance could be given to you. Okay, but just search for the word mean. That is under question number 33, 34, and 38. Now, if there are no words like mean and average, if the data is related to standard deviation, okay, or variance, only standard deviation or only variances will be given. In that case, it will be to test for the variance value or the standard deviation value. Okay. Now, if in the data, a table is given where the data is related to before and after something, some event, okay, then it is paired t-test. Remember, this is how you identify easily. Okay. Now, if there are no words like say mean, average, standard deviation, variance, then check whether there is a word like proportion or there is a percentage value or a point value, then it will be test for proportion. Okay. Now read this question number 33. They are saying among 400 randomly selected persons of a city, 280 like ice cream. Okay, test at 1% level of significance, LOS, that 50% of the people in that city like ice cream. So we have to test whether 50% of the people in that city like ice cream. Now, what is the test statistic that we have to use? What is a test about? What are we testing about? Is it for mean? Is it for mean? No, it is not for mean. So 5 formulas that we have written to test for mean cannot be used. Then, is there word like variance, standard deviation? No, then it is not test for variance. Is there any observations given in a table where you're testing the given observations? Observed data is given and you're testing that observed data. Any frequencies are given that we are testing here in the table? No, then it is not goodness of fit. Then, is there a 2 by 2 contingency table? Can you present this data in a 2 by 2 contingency table? No, that is also not possible. Then, is it test for proportion? Yes. So they are asking us to test that 50% of the people in that city like ice cream. So based on the qualitative data attributes, so it is test for proportion. Okay. So let us write the given values. What is N? Or you can write the test statistic also. Okay. You can write the test statistic also in the beginning. One second. Okay. So what is our formula? It is large sample test. It is large sample test. So Z is equal to P minus P naught. P minus P naught square root of P naught Q naught by N. Where P is the sample proportion. P is the sample proportion. P naught, capital P naught is the percentage or the proportion value that we are testing. What are we testing here? What are they asking us to test? They are asking us to test at 1% level of significance that 50% of the people in that city like ice cream. So we are testing whether 50% of the people in the city like ice cream. So what is the value to be tested? What is the proportion value or the percentage value to be tested, dear students? Yes, it is 50%. 50% is nothing but 0.5, 50 by 100. Now, small p is the sample proportion. Sample proportion. Now, we are given with the information that out of 400 randomly selected person, 280 like ice cream. So, it is x by n. Out of n sample selected, x possess the attribute. X contains that quality. So, how many individuals out of 400? 280 like ice cream. So what is the sample proportion? What is 280 by 400? Yes? What is 280 by 400? It is 0.7. Okay, it is 0.7. Q naught is 1 minus P naught. It is capital Q naught. So 1 minus P naught will be 0.5. 0.5. Now, your test statistic, sorry, normal 0, 1, standard normal distribution. This carries 1 mark. Okay. Writing the test statistic carries 1 mark along with the distribution. Along with the distribution. Now let us state the hypothesis H naught and H1. What is H naught? What is H naught? What is H naught? Yes? What is H naught? What do you mean by H naught? What do you mean by H naught? Yes, what is the meaning of H naught? I'm asking, what do you mean by H naught? Yes, Mayur, Savitri. What do you mean by H naught? H naught is the null hypothesis. The hypothesis which is tested for possible rejection. And in this case, we are testing that 50% of the people in that city like ice cream. So H naught P is equals to P naught. Okay, this notation is important. More than the statement what we write there, the notation, the symbols what you write, that carries mark. Okay, so always, whenever it is a concept of inference, dear students, for the population, based on the sample, we write the inference there. Okay, it is for the population, but depending on the samples, we give a conclusion for the given problem. So in this case, it is capital P is equals to P naught, and P naught is a value to be tested 0.5. That means, yes, this means we say that 50% of the people in the city like ice cream. Like ice cream. Okay. So this carries mark. Okay, this carries mark. P is equals to P naught. You can write the statement or you need not have to write the statement. Statement doesn't carry any mark, but you can beautify or improve the standard or the quality of your answers, okay, by writing the statements, okay. Now H1, alternative hypothesis. P not equal to P naught. P not equal to 0.5. That means we say that the proportion is not equal to 50%. Proportion of the people who like ice cream is not equal to 50%. Not equal to 50%. Okay. So I've already written the test statistics. Now let us substitute the formula. I mean values. Okay. Let us substitute the values. Okay. P is 0.7 minus 0.5 divided by a root of 0.5 into 0.5 divided by n, 400. Can you tell me the answer? What is the answer that we are getting? 8. Is it 8? 0.7 minus 0.5, that is 0.2 divided by 0.5 into 0.5 divided by 400, root of that 0.025. Yes, 0.025. So 0.2 divided by 0.025 will be equal to 8. Okay, 8. Now this carries 1 mark. Okay, your hypothesis carries 1 mark. H naught and H1 carries 1 mark. The test statistic formula carries 1 mark along with the distribution. The answer carries 1 mark. So altogether 3 marks. Now next we have to write what is the level of significance given. What is the level of significance mentioned? What is the level of significance? Alpha. Alpha is a level of significance, 1%. So we take 1% chance of giving a wrong decision. Okay. What is level of significance? It is a maximum size of the test. What is size of the test? Size of the test is probability of type 1 error. Okay. So we take 1% chance of giving wrong decision. So alpha is 1%. 1%. So whether the test is one-tailed or two-tailed. Whether the test is one-tailed or two-tailed. How do we know that? It is two-tailed. So you have to check your alternative hypothesis H1. If H1 is not equal to, say H0, the condition will never change for any given problem. H0 should be equal to something. Okay? Should be equal to something. Population parameter is equal to some value that is given for testing. Okay, under H1 could be either not equal to, it could be more than something, it could be less than something. Whenever it is not equal to, we say that the test is two-tailed. If it is greater than or less than, we say that the test is one-tailed. If it is greater, your right hand symbol. If it is greater, we say a right-tailed test. If it is less than, we say that it is left-tailed test. Now, in this case, the test is two-tailed. Two-tailed. Okay. What is a critical value? This carries mark. We have to read from the table. What is a critical value? Critical value. Okay. So it is normal distribution. Yes, normal test, Z test. So it is 1%, two-tailed, 1%. What is the critical value, dear students? 2.58. It is 2.58. So our critical value is 2.58. So it is minus 2.58 and plus 2.58. Two-tailed. Okay. So that carries 1 mark. So with the help of the curve, you can conclude the test. So the rejection region lies on both the tails. Okay. Then the test is called as two-tailed test. So rejection region on both the tails. Unshaded part will be acceptance region. Now you have to check whether your answer falls in the rejection region, the shaded area, or in the unshaded area. Our answer is 8. Our answer is 8. It falls to the right side of the tail and it falls in the rejection region. So we conclude H0 is rejected. So in your answer, while evaluating, we search for this conclusion, whether H0 is accepted or rejected. This carries 1 mark. Your table value carries 1 mark. So altogether 5 mark is the weightage. Okay. The hypothesis H0 and H1. H0 and H1 carries 1 mark. The formula for Z or T carries 1 mark. The calculated value carries 1 mark. The critical value carries 1 mark. The conclusion, whether H0 is accepted or rejected, carries 1 mark. Okay, so altogether the weightage is 5 marks. Is that clear? Okay, we'll move on to the next sum. I suppose there is no doubt. Shall we move on, students, for the next sum? Yes. Okay. The next question. Okay, read the question. Go through the next sum. Okay. From the following data, test whether mean of the first population is greater than the mean of the second population. Mean of the first population is greater than the mean of the second population. So they are asking you to test whether mean of the first population is greater than the second population. So this is test for mean. We are testing for mean value. right? How many sets of data they have given? How many sets of data? 2 sets of data. What is a sample size? What is a sample size? Whether n1 plus n2 is greater than 30 or it is less than 30. N1 plus n2 is greater than 30 or less than 30. It is less than 30. So altogether, whenever 2 sets of data is given, we have 2 formulas. One is x bar 1 minus x bar 2 by sigma 1 square by n1 plus sigma 2 square by n2. This is large sample test. Okay. And one more is t-test, that is x bar 1 minus x bar 2 by root of sc square 1 by n1 plus 1 by n2. Now here, the sample size is small. Whether we have to use a z-test or t-test. Whether it is z-test or t-test. Yes, it is t-test because the sample size is small. The size is 10 and 12, which is 22, less than 30. So we go for t-test. So let us apply t-test over there. Okay. So let me write down the given values. So N1 is 10, N2, the sample size is 12, number of observations considered. Mean, sample mean is given, x bar 1 is 62, x bar 2 will be 55. Variance is given. Be careful, variance is given. It could be standard deviation also sometimes. Okay, so variance, it is S1 square 16 and S2 square is given as 25. Now let us state the hypothesis. Okay, hypothesis, H0 and H1. What is our hypothesis? They are asking us to test whether the mean of the first population is greater than the mean of the second population. So we always test for the population parameter. Under H0 and H1, it should be the parameters. Okay, population parameters. Mu1 is equal to mu2. 2 sets of data is given. You're testing for mean. So whenever it is mean test, if it is single set, it is mu is equal to mu naught. If it is 2 sets, it will be mu1 is equal to mu2. If it is proportion, single set P is equal to P naught. 2 sets, it will be P1 is equal to P2. Similarly, whenever we are testing for variance, it will be sigma 1 square. Sigma square is equal to sigma naught square. If it is standard deviation, we write sigma is equal to sigma naught. Okay. So in this case, we are testing for mean and we state mu1 is equal to mu2. That means what should be our statement? The statement doesn't carry mark, only the notation carries mark. Okay. What should be the statement? As I told you, you can improve the quality of your answers by writing the statements over there. Okay, we say the means of 2 samples are same, or the means are same. Sorry, means of 2 populations are same. Population are same. Or means are equal, a simple statement. Now, mu1 and mu2. What is the condition? What is the condition? What are they asking us to test? Yes? What are they asking you to test? Yes, whether mean of the first population is greater than mean of the second population. Mean of the, you can write the statement as mean of the first population is greater than mean of the second population. So we write the test statistics under null hypothesis under H0. The test statistic is x bar 1 minus x bar 2 by a root of SC square 1 by n1 plus 1 by n2. And write the degrees of freedom. It is n1 plus n2 minus 2. So this carries 1 mark. So 1 mark for the hypothesis, 1 mark for the formula along with the distribution. Okay. SC square is a combined standard deviation, combined variance, and it is n1 s1 square plus n2 s2 square by n1 plus n2. What is the value? What is the answer, dear students? 10 into 16 Don't square the value because variance is given to you. Plus N2 is 12. 12 into 25 divided by N1 plus N2 minus 2. That is 10 plus 12 minus 2. Can you tell me the answer? Yes? What is the combined variance? 10 into 16 plus 12 into 25. What is the answer? Combined variance? 23. Okay, 460 divided by, okay, 23. 23. Yes, 23, Mayur. Okay, now let us substitute. T will be equal to x bar 1, the mean of the first set, that is 62 minus 52, 55, divided by a root of 23 into 1 by n1 plus 1 by n2. Can you tell me the answer? What is the answer? It is 1.53. 1.538. Okay, calculated value. So this carries 1 mark. Is it 1.53? Yes. What about others? Are you getting the same answer? 1.5385. 1.5385. Okay. What is the level of significance? Alpha. What is the level of significance given to us? What is the level of significance? Alpha. Alpha is 5%. Right. Alpha is 5%. Critical value. One-tail test. It is one-tail test. What is the critical value? It is greater than right-tailed. So to the right side. Okay. What is the critical value? From the table, 5%. Degrees of freedom. Sorry, very sorry. Degrees of freedom, N1 plus N2 minus 2. Degrees of freedom. So that is 20. For 20 degrees of freedom, okay, T. For 20 degrees of freedom, 20 degrees of freedom, okay, it is one-tailed test. Alpha is 5%. One-tailed test, alpha is 5%. What is the table value? Yes, it is 1.73. 1.73. That carries 1 mark. So it is 1.73. Critical value is 1.73. Along with the degrees of freedom, you have to write the table value. So 1.73. 1.73. Okay. We accept or we reject? Our answer is 1.5. Critical region is from 1.73. So it falls in the unshaded region. That is our acceptance region. So we accept H0. We accept H0. We accept H0. That carries 1 mark. Is that clear? It was small sample. 2 sets of observations are given to us. And they are asking us to test whether the mean of the first population is greater than mean of the second population. It is small sample test, T test. And our conclusion is that we reject H0 and we accept H1. Sorry, we accept H0. Sorry, we accept H0. And we say that means of the 2 populations are same. Means are same. Okay, so that is question number 33 and 34. We'll solve few more sums on inference. Shall we solve few more sums on inference? Yes, dear students, from all the test statistics. Okay. Yes. Okay. So read the first question. Is the question visible? Is the question clear to you? Yes. Okay. We'll continue with the discussion of the sums from statistical inference. Yes. A sample of 50 children is taken from the school. A sample of 50 children is taken from a school. Average weight. Variables are given. Measurable quantities. Average weight. There is word average. Children is 28 kg. Standard deviation is 5 kg. Okay. Now they are asking us to test. Test at 1% LOS whether the average weight of the children is less than 30 kg. So we are testing whether the average weight is less than 30 kg. Are we testing for mean value here? Is it mean test? Is it mean test? Yes, it is mean test. What is the sample size? If it is mean test, if we are testing for the average value, we have two test statistics. One is Z test, one is T test. T is for small, Z is for large. What is our sample size? How many children they have taken from the school? It is 50 children, so it is large sample test. So it is Z test. Okay, let us write down the statistics given to us. Sample size is 50. And for these 50 children, what is the average weight given? So we have two notations for mean, dear students, mu and x bar. Mu is for population. Okay, mu is for population. Sigma is for x bar is for sample. X bar is for sample. Okay, similarly, we have sigma for population standard deviation, S for sample standard deviation, sigma square for population variance, S square for sample variance. Now, in this case, the average weight of the children for 50 children sample is 28 kg, X bar. SD is given as 5. So, it is for these 50 children. So, S will be taken as 5. Okay, sample standard deviation. Mu, the mean, population mean or the value to be tested. What is the value to be tested? What is the average value that they are asking us to test? So it is 30. So mu, that is a population parameter. Mu naught, since we are testing that value, we denote it by 0. So mu naught is 30 kg. So we state the hypothesis, which carries 1 mark, H naught and H1. The null hypothesis, mu. We are testing for the parameter always. Mu is equals to mu naught. Mu naught is 30. Data is regarding average weight. So our statement will be average weight of the children is 30 kg. Average weight is 30 kg. Mu. What are they asking us to test? So they are asking us to test whether the average weight is less than 30. Mu is less than 30. L, left hand, less than 30. So average weight is less than 30 kg. Less than 30 kg. So under null hypothesis, we have the test statistic as Z is equal to X bar minus mu naught. Dear students, in this case, we are given with the sample standard deviation. So your formula will be S divided by root N. Follow standard normal distribution. Don't write it as sigma. It is S here since sample standard deviation is given. Will you substitute and tell me the calculated value? So X bar is 28, mu naught is 30, S is 5, root N is 50. What is the test statistic value? Yes, 28 minus 30 is minus 2 divided by 5 by root 50. Can you tell me the answer? What is the answer? Yes? Answer is yes, Nishal, minus 2.82. Is that correct? I hope all the others are getting the same answer. Are you calculating? Yes. So it is minus 2.82. Alpha is given as level of significance is given as 1%. We take 1% risk of giving wrong decision. Okay. What is the critical value? Test is one-tailed or two-tailed? One-tailed or two-tailed? It is one-tailed. Lower or upper? Left or right? Less than L. So it is left-tailed. Yes. So test is left-tailed or one-tailed. Critical value, which carries mark. 1% from the table. Critical value. Critical value from the table. One-tailed. Normal test. Yes. Minus 2.33. Since it is left-tailed, it is minus. Okay. So critical value will be minus 2.33. Minus 2.33. We draw the curve. Okay. It's a symmetric curve. Okay. So left-tailed minus 2.33. We accept or reject. The shaded part will be rejection region. Left-tailed. So answer is minus 2.82, which falls after this critical value or the table value. So we reject H0. We reject H0 and accept H1. If you write reject H0, that is enough. It is understood that you are accepting H1. Or else you can write accept H1. So we say that the average weight of the children is less than 30 kg. So in this case, sample size was large. Single set of data is given to you. Single sample is given to you. So it is large sample test testing for the mean value. Okay. Moving on to the next sum. Moving on to the next sum. Remember question number 33 and 34 and 38. Okay. In the question paper. Okay. So next question. Next question. So read the next question. From the following data, test whether literacy and smoking are independent at 5% level of significance. There is a word independent. Okay. And literacy and smoking are attributes. And the data is given in a 2x2 contingency table. So what is the test applied here? Data is presented in a 2x2 table. And we are testing whether literacy and smoking are independent. So it is test for independence of attribute. Chi-square test. Yes. Chi-square test. Chi-square test. Okay. So H0 and H1. H0 and H1. So there is no notation here. There is no notations. Okay. We are testing attribute A and B are independent. Literacy and smoking. Literacy and smoking are independent. So use the word independent under H0. Don't write dependent or not independent. You have to write the word independent here. Okay, so literacy and smoking are independent. Literacy and smoking are not independent or dependent under H1. Okay, so our formula under H0, the test statistic. Chi-square is equal to n into AD minus BC whole square divided by the row total and the column total. Test statistics carries mark C plus D into A plus C into B plus D, which follows chi-square with 1 degrees of freedom. 1 degrees of freedom. Okay. So let us substitute. Help me with the answer. What is the total frequency N? 20 plus 18 plus 15 plus 25. What is the total frequency N? 78. Okay. So into AD, the cross product, that is 20 into 25 minus 18 into 15 whole square. divide by the row total. 20 plus 18 is 38. 15 plus 25 is 40. Into 20 plus 15 is 35. Into 18 plus 25. 18 plus 25. That is 43. What is the answer? Can you tell me the answer? Okay, so 20 into 25 minus 18 into 15 into 78 divide by 38 into 40 into 35 into 43. What is the answer? Is it 1.80? Is it 1.8037? What is the answer, dear students? Is that the answer? Yes, 1.8037. Okay. So test is one-tailed. Test is always one-tailed. It is always one-tailed. Okay. Always one-tailed. Chi-square test for independence of attributes. It's a one-tailed test. Alpha is given as 5%. For 5%, what is the critical value? Chi-square table value. Either it should be 6.65 or 3. Okay. So chi-square table. Yes. 3.84 for 1 degrees of freedom. 5%. One-tail test. So the critical value will be 3.84. 3.84. Okay. So critical value is 3.84. Critical value. So chi-square test is a right-tailed test. Positively scaled. Range is from 0 to infinity for 1 mark. Okay, so it is one-tailed, right-tailed. Okay, it is 3.84. Your answer is 1.80. Accepted. Very good, Nichelle. So we accept H0. We accept H0. So chi-square test. Okay, chi-square test. We'll move on to the next question. Okay. See the next sum. For the following data, test whether there is any significant difference in the population proportion. There is word proportion. So it is proportion test. 2 sets of samples are given to you. So what is our formula? Okay. So H0, P1 is equal to P2. Proportions are same. No difference. There is no difference. It is same. Okay. There is no difference in the proportion. H1, P1 not equal to P2. There is no word like greater, above, below. So they are asking you to test whether there is difference or there is no difference. So P1 not equal to P2, there is difference. It is not same. Okay, it is not equal, not same. So there is significant difference. Yes, there is significant difference. Any doubt? There is significant difference. So large sample test, it is proportion test. So P1 minus P2 by root of P cap, Q cap, 1 by N1 plus 1 by N2. So this follows standard normal distribution with mean 0 and variance 1. So P hat we have to calculate. What is given to you? So they have given us N1, the sample size, and the proportion is 0.02, N2 110, and the proportion P2 0.01. So Q1 will be equal to, okay, Q1 is not required. Okay. So P hat, how do we calculate? N1 P1 plus N2 P2 divided by N1 plus N2. What is P hat? Can you calculate and tell me the p hat value? Yes. What is p hat? What is the value? N1 P1 plus N2 P2 by N1 plus N2. Yes. Mayur, Savitri. What is p hat? Substitute the given values. Okay, so it is 100 into 0.02 plus 110 into 0.01. Okay, so Nishil, it is 0. Thank you, 0.0147. Q hat will be 1 minus P hat. 1 minus P hat. So 0.9853. Yes, 0.9853. Substitute. Find the answer. P1, the proportion is 0.02 minus 0.01 divided by a root of P hat 0.0147 into 0.9853, 1 by N1 plus 1 by N2. So what is the answer we are getting? What is the answer we are getting? 0.0147 into what is the answer? Yes? I hope you are calculating. What is the answer? Yes, students? Zero 0.7299. Okay. 0.01. 0.7299. I hope all are getting the same answer. Yes, 0.7299. Alpha is given as 5%. Alpha is 5%. It's a two-tailed test. Critical value is read from the table. It's a two-tailed test. Symmetric curve. Minus 2.5%. What is the critical value? 1.96. Correct. Minus 1.96 and plus 1.96. So we reject or accept H naught. The shaded region is the rejection region. Your answer is 0.7299. So we accept H naught. We accept H naught. A sum for 5 marks. Okay? Yes. So next question. Next question. I hope there is no doubt in that sum. Test for proportion. So we discussed independence of attributes. We discussed single mean test, small sample, large sample. Now two sets of proportion. Now see the next question. Marks scored by 9 students in test conducted before coaching and after coaching are as follows. Test whether coaching is effective. You have to test whether coaching is effective. So I told you, dear students, in the question paper, whenever there is a data which is related, correlated, and if the data is regarding a variable which is observed in two different time points, okay, then it will be test for paired t-test, where the variables are correlated and One more easy way to identify is data will be before and after, usually. Okay. So in this case, it is before coaching, after coaching. So we are testing whether coaching is effective. So it is paired t-test, H naught. It is mean test. Paired t-test is testing for mean value, variable, marks they have given. Mu1 is equal to mu2. H1, what should be the condition? They are asking us to test. They are asking us to test whether coaching is effective. So when I write mu1 is equal to mu2, mu is mean, variable is marks. So I'm stating that mean marks are same or average marks are same. Mean marks are same before coaching and after coaching. Now I have to test whether coaching is effective. When can I say that the coaching is effective? Marks should be better after coaching or before coaching? When can we say that the coaching is effective? After coaching, the marks scored, mean marks should be better or more. So mu2 should be greater. Mu2 should be greater, mu1 less than mu2. Mu2 should be greater. Okay, so we say coaching is effective. In this case, coaching is effective. In the first case, we say that coaching is not effective because mean marks are same. So it is paired t-test under H naught. Under H naught, T is equal to D bar by SD by root N minus 1. This follows T with N minus 1 degrees of freedom. Dear students, you have to help me out with the values. So D bar is summation D by N. Okay, and D is X minus Y or X1 minus X2. So X and Y. So D, difference. Difference, left tail test. Okay. Left tail test, correct. Okay. Can you calculate and tell me the D bar value, mean for the deviation? D will be 37 minus 48. Write the value. 76 minus 82. Write the value. So find the difference, add all the value, find D bar. So D bar is, values are not legible. Okay, 1 second. Is it clear, Nishil? Are the numbers clear? Yes, okay. So it is 37 minus 48 plus 76 minus 82. D bar. Yes, dear students, can you tell me what is D bar? Okay, 54 minus 71. 43 minus 56. 84 minus 89. 89. Okay. 53 minus 58 plus 67 minus 63 plus 13 minus 17. 35 minus 30. What is D bar? Did you get D bar value? Mean for the difference. 53 minus 35 minus 30. Minus 5.77. Mayur is getting the mean for the difference as minus 5.77. What about others? Are you getting the same answer? Minus 5.77. Okay. I'll go with that answer, minus 5.77. So we want the standard deviation SD, root of summation the d minus d bar whole square by n, or d square by n minus d by n whole square, sum of d by n whole square. Okay. So find this value, standard deviation. Calculate d square if you're going for this formula. Square these values, add and write the sum, substitute. You will get the t value. Okay. You will get some t value. So alpha is not given. So what is the level of significance that we'll consider? If it is not mentioned, it is 5%. We take maximum risk of 5% of giving the wrong decision. Critical value is read from the table, T table, based on the degrees of freedom. Degrees of freedom is n minus 1. How many observations are given to us? How many observations are given? So it is 9 observation. 9 minus 1, 8 degrees of freedom. Read the table value. T table value. For 5 degrees of freedom, it is 1-tailed, and 8. For 8 degrees of freedom, for 5%, it is T-tailed, a leptokurtic curve. So it is left-tailed, lower-tailed. So your critical value will lie somewhere to the left side. And if the calculated value falls in the rejection region, you reject. Otherwise, you accept H naught. Okay. Okay, we'll just identify the test statistics. Shall we take a break? Shall we take a break? Yes, dear students. Yes. Yeah. Before taking a break, just tell me, do you want me to discuss few more sums on this, or shall we go to the remaining concepts, remaining chapter? Is that clear how to identify the test statistics? Yes. Do you want me to continue with the same chapter or remaining chapters? Remaining. Okay. So we shall discuss SQC, statistical quality control, and the OR concepts. Okay, after the break. Continuing same chapter and the last chapter. Bhavana, what is the last chapter? OR, isn't it? Do you want me to discuss SQC? Because this is a last session. So if you tell me what are the concepts that you want to discuss, I shall continue with the same concepts so that your doubts are cleared. Yes? If you mention the chapter name, I can discuss. Do you want me to discuss SQC, statistical quality control, or only the OR concepts? What is it? OR, Nishil. Okay. SQC and OR. Okay, okay. So after the break, we shall continue with SQC and OR concepts. Okay. Yes. So we shall take a break for 10 minutes maybe. We'll meet at 11:25 or 11:30. Okay. Yes. Yes, are you all back, students? Yes? Are you all there? So shall we continue with the discussion of remaining chapters, that is SQC and OR? Yes, okay. So we just discussed question number 33 and 34, that is from the inference. Now moving on to the next question, that is question number 35 and 36 in the question paper is from OR, and Roman number 7, question number 39 will be from SQC. Okay, you can expect one 5-mark question from SQC and question number 35, 36 from OR, as well as question number 40 from OR. Okay. Yes. So question number, we shall discuss SQC, that is question number 39. Question number 39 from SQC. Okay. How many charts do we have under SQC? Statistical quality control. So what is SQC? What do you mean by statistical quality control? It's a statistical technique used to control the quality of the products. So how many charts do we have there? Yes? How many charts do we have? So we have 4 charts, 2 for variables and 2 for attributes. What are the control chart that we use for variables? We have X bar chart and R chart, that is mean chart and range chart. Mean chart and range chart. And for attributes, we have C chart for defects and NP or D chart for defectives. Okay, for defectives, yes. So altogether, we have 4 types of control chart. Okay, so X bar chart. So we have 3 limits over there, the central line, the lower control limit, and the upper control limit. We have 2 sets of formula when standards are given and when standards are not given. So similarly, we have R chart, range chart, when standards known and when standards not known. Okay, so we have the central limit. When standards are known, X bar dash, the lower control limit, X bar dash minus A sigma dash, and then X bar dash plus A sigma dash, the upper control limit. Similarly, we have the sets of limits when standards are not given. When we have to find the values, it will be X double bar minus A2R bar, and then X double bar plus A2R bar, where X double bar is nothing but sum of mean divided by K. And R bar will be the mean for range, sum of range divided by K. So similarly for R chart, we have the central limit. When standards are known, it will be D2 sigma dash, D1, D2, D3, D4. So D1 sigma dash, capital D2 sigma dash, R bar, D3 R bar, and D4 R bar. So R bar formula we have already written here. Okay. So N can be either 4 or 5. So you can see few constants here, that is D2, capital D1, D2, D3, D4, as well as A and A2. These are read from the table, statistical constants table for the control chart for N is equal to 4 or for N is equal to 5, the sample size. Okay. So those are the two charts that are available for variables. Next, we have for attributes, that is NP chart or D chart for defectives. And then we have C chart, which is for defects. 1 mark question. Okay, name the chart for defects, C chart. Name the chart for defectives, it is NP chart. And we have 3 sets of limits, lower control limit, upper control limit. When standards are known, it will be NP dash, NP dash minus 3 root NP dash Q dash, and NP dash plus 3 root NP dash Q dash. So basically we assume binomial distribution here. NP is the mean. So we use the mean formula and the standard deviation. Okay. X bar plus or minus 3 into the standard deviation. So root NPQ for binomial distribution, standard deviation. So when standards are not known, NP bar, small letter. For the samples, we have to find the mean. NP bar minus 3 root NP bar Q bar, and NP bar plus 3 root NP bar Q bar. Where P bar, we have to find the mean for the defectives. So P bar is equal to sum of D, the defectives, divided by N into K. So we divide by the product of N into K. So standards known and standards not known for NP chart. Similarly, we have for C chart, when standards are given, the central line will be lambda dash minus 3 root lambda dash plus 3 root lambda dash. So in this case, we take Poisson distribution because it is defects. So mean minus 3 into standard deviation. So lambda dash minus plus or minus 3 into lambda dash. So when we find the statistics, it will be C bar minus 3 root C bar plus 3 root C bar, where C bar will be equal to sum of defects divided by K. C. We denote it by C, the defect, sum of C by K. Okay. Yes. So we have 4 charts, X bar chart, R chart, NP chart, and C chart. And we have 8 sets of limit when standards known, when standards not known for all the 4 charts. So 8 sets of limits. So these are the formulas that we have to adopt whenever SQC sums are given. If it is X bar chart, check whether standards are given or not given. Select the respective sets of limits there. Similarly for R chart, defectives and defects. Okay, now let us go to the sums. Yes, okay. So this is question number. In the question number, it is question number 39. Okay, question number 39, Roman number 7. So here, in this section, under section C, Roman number 7, you have to answer any 2. So your first question is from normal distribution. Second question is from test statistic inference. Third question, that is question number 39, is from SQC. And the last question, in this case, it is replacement, but 95% it is a sum from LPP. Okay. It is LPP. Replacement sum will be asked under Roman number C, question number 36. Either it will be inventory or it will be replacement. Okay. Now coming back to question number 39. In this case, check the data given to you. The following data relates to number of knitting defects per unit length of cloth manufactured by a textile mill. Draw control chart with lambda dash is equal to 3. So lambda dash is given, but defects are given. So whenever defects is given, what is the chart that we use? Which control chart do we use whenever defects are given? Or name the chart that is used for defects. Which chart? It is C chart. Yes. So we go for C chart. As I told you, there are 2 sets of limits, standards given and standards not given. Yes. Now in this case, standards are given. the value is given, lambda dash is given to you, average number of defect is given to you. So standards are known. It's a simple chapter. So we have to find the three limits. C chart, standards are known. So we write the formula as lambda dash, lower control limit lambda dash minus 3 root lambda dash, and the upper control limit lambda dash plus 3 root lambda dash. Substitute the value 3 lambda dash, the central line will be 3. The lower control limit will be 3 minus 3 root 3, and the upper control limit 3 plus 3 root 3. Okay, can you tell me the answer? What is the lower control limit? 3 minus 3 root 3. So it is minus 2.196, which is approximately equal to 0. And then we have 8.196. So those are the control limits, a sum for 5 marks. Any doubt? C chart. In this case, standards are given. A simple sum for 5 marks. You just have to substitute the given values and then find the limits. The central line, the lower control limit, and the upper control limit. Yes. Shall we move on, dear students? Yes? Okay. Now I've taken few sums from SQC. You just have to identify and tell me the limits. Bhavana, I hope Bhavana is present. Are you there, Bhavana? Yes. See the first sum here. Question number 39, the question paper, Roman number 7. Okay. If the standards are known to be x bar dash is given, sigma dash is given as 6, n is given as 5. Okay, n is given as 5. Find the control limits for x bar chart. So they are asking you to find the control limit for x bar chart. Standards are known, x bar dash. So remember, whenever x bar dash, p dash is given to you, we go for the first set of limits. So it is x bar chart. So we have the central line as the formula as x bar dash. X bar dash is given to you as 20. Then we have the lower control limit, x bar dash minus a sigma dash. A is read from the table. What is n given to you, dear students? What is n given to you? Yeah, standards are given. What is n given to you? N is 5. So from the table for n is equal to 5, n is equal to 5, we read the a value from the table. What is a value in the table? So a is 1.342. A is 1.342. So substitute 20 minus 1.342 into sigma dash, which is given as 6. So 20 minus the product. 20 minus the product. What is the limit? 20 minus 1.342 into 6. So that is 11.94, right? 11.94. And we have the upper control limit as x bar dash plus a sigma dash. That is 20 plus 1.342 into 6. So that is 28.052. So done. So x bar chart and the limits, respective limits, the central line, the upper control limit, and the lower control limit. Okay, simple sum, that is question number 39. Moving on to the next question. The following data shows the value of sample means and ranges. Find the control limits for mean. They are asking you to find the control limits for mean. Are you there, Bhavana? Whether Bhavana is present? Can I get a yes from you, Bhavana? Yes? Okay, Bhavana, you wanted me to discuss SQC chapter. Are you there? Yes, okay. Now tell me, they are asking you to find the control limits for mean. Whether standards are given, whether the mean or standard deviation value is given. How to identify if the standard deviation value is given to you, standards are known. Okay, check for that value, sigma dash. If standard deviation is given in the statement, then standards are given. If it is not given, then we have to find. So standards are not known in this case. In this case, the standards are not known. So the limits will be, it is control limit for mean chart. So we have central line as x double bar, the lower control limit as x double bar minus a r bar, a2 r bar, and we have the upper control limit as x double bar plus a2 r bar, where x double bar we have to find, that is sum of mean divided by k. Okay, sum of mean divided by k. What is sum of the mean? Can you add and tell me the sum of mean? The sum. Can you tell me the sum? 20 plus 34 plus 45 plus 39 plus 23 plus 37, 34, 13, 29, 26. Yes? What is the sum? 300. So 300 by 10. K, number of observations given is 10. So that is 30. So we get x double bar as 30. R bar will be sum of range by K. Mayur, can you tell me the sum of range? Sum of range, R. Sum of range. +21 plus 17 plus 20, 200. Okay. So 200 by 10 is 20. So substitute. Therefore, the central line will be x double bar, that is 30. The lower control limit will be x double bar, that is 30 minus A2 is read from table. What is your N? What is the size of the sample given? What is the sample size given? Yes, it is 4. So for 4 from the table, what is A value? A is 1 point. A2 value, sorry. A2 is 0.729, A2. So we have 0.729 into 20. So 30 minus the product. 30 minus 0.729 into 20. So that is 14 point. You don't have to show the calculation here. Okay, so 30 minus 14 point will give you 15.42. Okay, similarly, we have the upper control limit as 30 plus 0.729 into 20. That is 30 plus 14.58, which is 44.58. So we have the upper control limit as 44.58, the lower control limit as 15.42, and the central line as 30. Okay, so mean chart. Moving on to the next question. Moving on to the next question. In order to test, okay, that is how we solve the sums under SQC, finding the limits. Now just check the question. In order to test whether the process of molding of bronze bearing casting, 6 samples of size 5. So 6 samples, size 5 each are taken, and the variation in the weights are given. Find the control limits for R chart, range chart. Whether standards are given. See, for mean chart as well as range chart, when standards are given, we need standard deviation value, that is sigma dash, to be known or given. Whether that is given here, whether standard deviation is given, dear students, whether standard deviation is given. No, it is not given. So we say standards are not known. So we go for second set of formula. It is range chart. So we have control limit as R bar. We have lower control limit as D3R bar and the upper control limit as D4R bar, where R bar is the mean for the range value, sum of R by K. So 2 plus 7 plus 6 plus 5 plus 8 plus 9. What is the sum? Can I get the sum? 2 plus 7 plus 6 plus 5, 37. 37 by 6, K is 6. What is 37 by 6? 6.166. So 17. So R bar will be 6.17. D3 is read from the table for n is equal to 5. So for n is equal to 5, D3 is 0. D4 is 2.115. Okay? 2.115. So we have 0 into any value is 0. And we have D4 from the table as 2115 into 6.17. So multiply and find the limit. So control limits for R chart. Control limit for R chart. The central line, the upper control limit, and the lower control limit. Okay. The next question. I hope it is clear. 10 samples of each of 50 items were inspected. Number of defectives are given. Defectives. So find the control limits. So if defectives are given, what is the control chart that we use for defectives? Very good. It is NP chart. Yes, it is NP chart. Whether standards are given. See, NP chart, as I told you, we assume binomial distribution, where P is the proportion of defectives or probability of defectives. Okay, or percentage of defectives. Now, in the question, did they mention the proportion of defective is so much, or probability or percentage of defective is this much? Whether any value is given, specified in the statement? Is it given, dear students? No, it is not given. So we say that standards are not known. Proportion or percentage is a point value. Check in the statement whenever defectives are given, any point value is specified and given as proportion or percentage or probability of defectives. If it is not given, standards are not known. You have to find the values. So standards not known. The central line will be NP bar, small letter p. If it is given, it is capital P. It will be for the population. A general value will be given. Now for the sample, you are finding the statistics. So we take it as P bar. Okay, so the lower control limit will be NP bar minus 3 into NP bar Q bar. We have the upper control limit as NP bar plus 3 into root of NP bar Q bar, where P bar, the mean defectives, sum of D by N into K. So K will be the number of observations in the table, that is 10. Sum of D will be the number of defectives given. What is the total number of defectives, dear students? 25. So 25 divided by N. N is the size. Under each sample, 50 items are taken. So 50N, K will be 10. So what is P bar? Can I get P bar? Yes. What is P bar? Yes, students, what is P bar? 25 by 500. So 25 by 500. What does that? 550.04. Nishil, check the answer. 25 by 500. It is 0.05. Yes, P bar. Q bar is 1 minus P bar, that is 0.95. Substitute and find the answer. So your CL will be N, that is 50 into P bar, 0.05. The lower control limit will be 50 into 0.05 minus 3 into root of NP bar Q bar, that is 50 into 0.05 into 0.95. Okay. Similarly, find the upper control limit. So substitute and find the value. Calculation is very simple and the sums are also very simple. Okay. Any doubt? Shall we move on? Shall we move on? Yes, dear students? Yes, okay. Now moving on to the next question. Check the question here. In a floor mat manufacturing company, the average number of defects per square meter is known to be 4. Average number of defects. Which chart? When defects are given. What is the chart that we use for defects? Question for 1 mark. Name the chart. Yes, it is C chart. Average. C chart. We assume Poisson distribution. Lambda is average or the mean value. In this case, it is average defects, mean defects, whether that is given, whether mean defects is given to you in the data. Mean defects is given. Mean defects kotidarali. Yes, it is given. So standards are known. So we go for lambda dash. So CL is equal to lambda dash. LCL is lambda dash minus 3 root lambda dash. And the upper control limit is lambda dash plus 3 root lambda dash. So lambda dash is given as 4. So substitute and find the answer. Okay. Yes. So we'll move on to the next one. Following are the number of defects observed in cotton blankets passing from the process. Find the control limits for defects. So defects, again C chart, whether average defects is given to you or mean defects is given. Average or mean defect is given to you. It's not given. So we go for C chart when standards not given. So your central line will be C bar. Lower control limit will be C bar minus 3 root C bar. Upper control limit will be C bar plus 3 root C bar. Where C bar, the mean defects will be sum of C by K. So add all the defects. C will be the defects. Add all the defects. Divide by 8. K is 8. 8 observations. So find C bar, substitute and find the limits. Okay. Okay. The last sum. Calculate the control limit for R chart for the following data given n is equal to 5. So it is R chart. So we need standard deviation. It could be mean or it could be R chart. Whenever standards are known, we need standard deviation, which is not given. So standards are not known. So your formula will be R bar, lower control limit, D3 R bar, upper control limit will be D4 R bar. I think a similar kind of sum we have solved above. Yeah, here. Okay, this sum. When range is given. Okay. So I hope it is clear how to identify the set of limits. Any doubt under SQC? No. Okay. We shall move on to the next chapter, that is OR. OR. Okay. That is question number 35, 36 and question number 40. Question number 35, 36 and question number 40. So it is from LPP, that is question number 40. TP or game theory, question number 35. Inventory. Can you solve this LPP? Solve the following linear problem. Yes, 1 second. Okay. Yes, Nichelle, LPP. Let me copy the question. Solve the linear program. Maximize Z is equal to 3x plus 5y. Subject to conditions x plus 2y less than or equal to 20. Y less than or equal to 6. And the non-negativity restriction x and y greater than or equal to 0. Okay, so this is the LPP given to you. Maximize Z, 3x plus 5y. Nichelle wants me to solve a sum from LPP. Okay. So question number 40. LPP is question number 40. So it's a graphical method that we use here. So we need to find the pair of observations to be plotted for the two given inequalities. So the inequalities are considered as equations. Two inequalities are given. Two inequalities are given. which we have to consider it as equation. Take x as 0, find the value for y. Take y as 0, find the value for x, and then find the pair of points to be plotted. Okay. Now this table value, this value, the pair of observations to be plotted carries 1 mark. Okay. So let me write the first equation. The inequality is considered as equation. So x plus 2y is equals to 20. So less than or equal to 20, we consider it as equation. Now when x is 0, what will be your y value? So we get 2y is equal to 20, right? Our x is 0. Y will be equal to 20 by 2. You don't have to show the calculation. 20 by 2 is 10. So online classes, there are few limitations. So I am showing the steps here. 2y is equal to 20, y is equal to 20 by 2, that is 10. Now when y is 0, what will be our x? When y is 0, our x will be 20. Okay, yes. So the pair of points to be plotted will be x 20, y is 10. The second inequality, so you can see the inequality, it is y less than or equal to 6. So we write y is equal to 6. X is taken as 0, y will be equal to 6. There is no x given. So your x is 0, y is 6. Okay, Nishal, our x will be 0, y will be 6. Now in the graph, if you observe, all the 4 values to be considered falls in the first quadrant. So x-axis, y-axis. So x takes values 20 and 0. Y takes values 10 and 6. So we shall take the scale as 5, 10, 15, 20 for x-axis. So mention the scale since it is graphical method. X-axis 1 centimeter, 5 units. Y-axis, the values taken will be 10 and 6. So we take 2 units. 1 centimeter is equal to 2 units. So it is 2, 4, 6, 8, and 10. Okay. Now the pair of points to be plotted will be 20 and 10. X is 20. Okay. Y will be 10. 20 and 10. Okay. So use scale and join the points, plotted points. Okay. So the inequality equation is x plus 2y is equal to 20 in that case. Nishal. Now the second one, it is x0, the pair of points. It is x0 and y6. Okay, x is 0 and y is 6. So we draw a parallel line to the x-axis. Whenever y values are given, x is not given, it will be a parallel line to the x-axis. If x is given and y is not given, then a parallel line to the y-axis. Clear? Okay, so the equation here will be y is equal to 6. Now let us consider the inequality sign what is given. X plus y is less than or equal to 20. Nishal. Now here, the inequality is less than or equal to. Okay, less than or equal to. So whenever the inequality sign is less, okay, less, all the points associated with that line should move towards the origin, towards 0. Okay, never say downwards or upwards. Say towards origin or away from the origin. Now here in this case, all the points associated with this line will go towards 0. Now 0, as you see, it is below this line. So it should go in this direction. Okay, so it will move in that direction. Okay, so in this direction it is. Okay. The second inequality, y is less than 6 again. So inequality sign is less. Inequality sign is less. So all the points associated with this equation, y is equal to 6, again will move towards 0, in the direction of 0, towards the direction of 0. So it will be like this. Okay. Yes. Okay. Now you have to search a common shaded region in the first quadrant here, which is called as the feasible region. Is there a common shaded region, a feasible region? Yes. So as you can see, this is the feasible region. Okay. This is the feasible region. This is the feasible region. So mark the corner points. Mark the corner points. So there is one corner here, A. Sorry. There is one corner point here, A. Okay. Then we have one more corner point, B. Then one more corner point, C. And one more corner point, D. So four corner points. So write the corner points. Let us find the basic feasible solution. So our objective function, the objective is to find a maximum value for Z. It is to find a maximum value for Z. So maximize Z is equal to 3x plus 5y, 3x plus 5y. Read the value from the graph. A is x0, y6. Substitute Z is equal to 3 into 0 plus 5 into 6. So 0 plus 30 is 30. B, since I'm not using graph here, approximate nearest value I will write. So x may be somewhere around say 6. Y is also 6. Okay, you can see x somewhere it will be here. So I'll take it as 6. Okay, I am not using graph here. So rough figure Z is equal to, if you use graph, you will get an exact value there. So 3 into 6, your x is 6 plus 5 into y is 6. So 18 plus 30, 48. Okay, then we have another corner point C where your x is 20. Yeah, x is 20, y 0. So Z will be equal to 3 into 20 plus 5 into 0. So 320s are 60. 60 plus 0 is 60. D we don't consider because both x and y are 0 there. When you substitute, you will get the Z value as 0. So we don't consider. Now our intention is to find a maximum value for Z. Which value is maximum here? Which value is maximum? 30, 48 or 60? So we can see that 60 is maximum. Yes, maximum. So we write optimal or optimum value. This carries 1 mark. If you don't write this, you will lose mark. Okay. Optimum value Z is equal to 60. Optimum solution. Optimum solution. X is equal to 20. Y is equals to 0. So this carries 1 mark. Your graph carries, the values carries 1 mark. The lines associated, the straight line associated with the equation carries 1 mark. The feasible region carries 1 mark. Okay. And the calculation part, if it is there, carries 1 mark. So altogether, it's a 5 mark sum. Optimal solution, x 20, y is equals to 0. Why it is called as an optimum solution? Optimum solution, optimum feasible solution. What is a solution? What is a feasible solution? What is an optimum feasible solution or basic feasible solution? Only one solution is unique solution. If an LPP has only one solution, then it is called as unique solution. Why do you call it as optimum solution? Question could be asked for 1 mark. What do you mean by optimum solution? Optimum feasible solution in an LPP. What is that? The set of real values of x1 to xn. In this case, we have taken x and y. Set of real values of x1 to xn, which satisfies the constraints, okay, that is ax less than, greater than, or equal to b, non-negativity restrictions, and which optimizes the objective function. Optimizes the objective function is called as optimum solution or basic feasible solution. Okay, is called as optimal feasible solution. If it satisfies all the three conditions, the constraints, the non-negativity restriction, and if it optimizes the objective function, then only we can call it as optimum solution. Now, in this case, your optimum solution is x20 and y0. So, substitute in the constraint x plus 2y is equals to 20. Your x is 20, y is 0. So 2 into 0 is 0. What is 20 plus 0 is 20. So constraint is satisfied. Y less than or equal to 6, the second constraint. Your y is 0. E is 0 less than 6. E is 0 less than 6. Yes. It is less than 6. So it satisfies the constraints. The solution what you are getting satisfies is said to be basic feasible if number of positive allocations are yes. Yes. Optimum solution. Okay, optimum solution. It should satisfy the three conditions, the constraints, the non-negativity restriction, as well as optimizes the objective function. So both the answers 20 and 0 for x and y, both are positive, satisfy the non-negativity constraints, as well as it gives you the maximum value for z, which is optimizes the objective function. So hence it is called as optimum solution. Don't get confused with the answers for transportation problem and LPP. Basic feasible solution, optimum solution, and feasible solution. Okay? Yes. Nishal, I hope your doubt is cleared. LPP. I'm facing difficulty with finding feasible region. Okay. Okay, LPP. You want me to solve more sums under LPP? Bhavana. Let me check whether I have questions here. Okay. I hope the question is visible. Okay, I have taken two questions here. Minimum. Okay, minimize z is equal to minimize. Okay, minimize z is equal to 5x plus 8y, 3x plus 2y less than or equal to 18, 4x plus 3y more than or equal to 12. Yes, Bhavana. Tell me the pair of points to be plotted. Okay, so 3x plus 2y is equal to 18. If x is 0, what will be y? When you take x as 0, what will be y? Y will be 18 by 2, that is 6. Sorry, 9. Very sorry. Yes. And if y is 0, we get x as 6. So the pair of points will be 6, 9. Pair of points will be 6, 9. For the second equation, 4x plus 3y is equal to 12. Bhavana, if x is 0, what is y? What is the value that you are getting? If x is 0, y will be? What will be y? 4. If y is 0, x will be? Y 0. X will be? What is x? 12 by 4. That is 3. Okay, so 3 and 4. 3 and 4, yes. Now all the values are positive. So we take the first quadrant. We take 2, 4, 6, 8, and 10. 2, 4, 6, 8, and 10. Bhavana. Okay? Yes. Now, for the first equation, 6 and 9. Y is 9. So, join the points. So, the equation is 3x plus 2y is equal to 18. Okay, the next pair of point is 3 and 4. X is 3, y 4. Okay, so the equation is 4x plus 3y is equal to 12. Now check the inequality sign. Bhavana, it is less than, less for the first equation. For this line, it is less than. If it is less, all the points associated with that line should move towards origin or away from origin. 0 ಕಡೆಗೆ ಹೋಗ್ಬೇಕಾ ಅಥವಾ 0 ಇಂದ opposite direction ಅಲ್ಲಿ ಹೋಗ್ಬೇಕಾ? Bhavana. If the inequality sign is less, it should move towards origin. So all the points associated with that equation will move towards origin. Okay, yes. Now the second inequality sign is greater than. Now the points associated with that line should move towards or away, away from origin. Towards origin or away from origin. So it should move away from origin. Okay. So away from origin. So is there a feasible region, common shaded region? Is there a common shaded region where both the shades meet? Bhavana. Yes. So this will be the common shaded region, which is called as feasible region. Mark the corner points. Mark the corner points. So A, B, C, and then D. So 4 corner points. Is that clear, Bhavana? Yes. Write the corner points and find minimum value for Z. So our Z objective function is 5x plus 8y. Read the corner points A. A will be x0, y9. Substitute. Z is equal to 5 into 0 is 0. 8 nines are 45. So you have to substitute here. So that is 45. Similarly, we have B as x6, y0. So Z will be equal to, your Z will be equal to 5 6 are 30. 30 plus 0 is 30. C, x3 and y0. So your Z will be equal to 5 3s are, your x is 3, substitute. 5 3s are 15, 8 zeros are 0. So 15 plus 0 is 15. And D, another corner point where your x is okay, y is 4. x0, y4. Substitute. So y is 4. 5 zeros are 0 plus 8 fours are 32. So 32 plus 0 is 32. And our objective is to find a minimum value for Z. Which is minimum here? Which is minimum? C. Okay. So this is minimum. So we write optimum value Z is equal to, which you have to mention in the exam, optimum solution x3 and y is equal to 0. Unique solution. LPP has unique solution. Okay. I hope your doubt is cleared, Bhavana. That is how we find the feasible region Many sums are solved sums are there in the textbook. You just go through those sums or solve those sums. Just try to find the feasible region. Okay. Feasible region is a region where all the points associated with the inequalities, the equations, meet up in one common area in the first quadrant. Okay, that is a feasible region. Graphically, the common shaded area. Okay, yes. So we'll move on to the model paper. That was question number 40. Okay, question number 40. LPP question. Okay, questions from LPP will be asked in Roman number 7. That is question number 40. Yes. Now question number 35. Question number 35. As I told you, it could be either from transportation or it could be from game theory. Now see the question. From the following transportation problem, find the initial basic feasible solution by matrix minima method. Okay, minimum method. How many methods do we have? How many methods do we have under transportation to find the solution, basic feasible solution? Two methods, matrix minima method or least cost entry or northwest corner rule. In this case, it is matrix minima method. Okay, matrix minima method. Okay. Do you want me to solve the sum? Transportation. Yes, dear students. Yes. Do you want me to solve this sum from transportation? Only if you tell, I'll solve. Yes, dear students, I'm waiting. No. Okay. What about others? There are two methods, northwest corner rule and matrix minima method. Okay. So next question is inventory. Rashika. Okay. All are familiar with both the methods, isn't it? Under transportation. Okay. Now, what are the points that you should consider while solving the sum? The very first step is to check whether the transportation is balanced. So sum of AI should be equal to sum of BJ. In this case, the total is not given. Total available items and the total items in demand. So which you have to add and find the total. So there is a value missing here. You can see there in the question. What is the total items available? Yes, dear students, how many items are available? 350, 100 and 110. What is the total? 560. Okay. So what will be the remaining items to be supplied or in demand? How many items are in demand, which is not mentioned here? Question is correct. Our question is correct. Don't think that it is wrong. Yeah, 360. So you have to write it as 360. Now, in the very beginning, you have to check whether the transportation problem is balanced. So is it balanced here? Sum of available items should be equal to sum of required items, 560. So TP is balanced. So that carries mark. Now, in this case, they are asking you to find the initial basic feasible solution as well as cost associated, minimum cost. So you have to allocate the items, searching for the minimum cost every time. So minimum is 4. So you have to write allocate XC3 minimum of 110 and 360. So minimum is 110. We allocate 110 items here. Okay, 110 items there. And we delete that particular row. We don't have to go to that place. So out of 360, 110. So likewise, you complete the sum. You will be doing the allocations over there. Okay, and then you have to mention the basic feasible solution, which is asked. XC3 is equal to all the allocations you have to write. Okay, so this carries 1 mark. Your method carries 2 mark. The method carries 2 marks. And then minimum cost, transportation cost. The formula carries 1 mark, double summation Cij into Xij. So this carries mark, this formula. So formula carries 1 mark and then the answer carries 1 mark. So altogether 5 marks. Okay, if suppose degeneracy is asked, whether the solution is non-degenerate or degenerate, the method may carry 1 mark and the degeneracy may carry 1 mark. They may not ask cost over there in that case. Okay, just check what is asked. Clearly mention whatever is asked to you there. Is that clear? You have to write the formulas. Wherever we calculate something, any measure, you have to write the respective formulas over there. Okay. Moving on to next question, that is question number 36. Either from inventory or it could be from a replacement theory. Okay. Now read the question here. Annual demand for an item is 4,000 units. Capital cost is 8 per unit. Inventory carrying cost is 15%. Setup cost is 150. Determine economic order quantity EOQ and the number of orders per, that is frequency of orders N naught. Now tell me, how many models are there in inventory? How many models are there in inventory? 2 models. Okay. What are the assumptions for model 1? What are the assumptions for model 1? Important question for 2 marks. Assumptions. What are the assumptions under model 1? Inventory is all about maintaining the stock of goods before they are sold or used. Okay. What are the assumptions that we have? What are the assumptions? Demand is uniform. Then uniform demand. Okay, in both the cases, that will be same. Uniform demand. Then instantaneous production. Yes. Instantaneous production. Yes. Then what about shortages? Shortages are allowed in model 1. Lead time is 0. In both the model, lead time will be considered as 0. Lead time is 0. Shortages are not allowed. In model 1, shortages are not allowed. Whereas in model 2, shortages are allowed. Okay, shortages are allowed. Shortages are allowed. Yes. Now in this question, is there any information regarding shortage? Penalty, inability? No. That means this is for model 1. So model 1 is used. Model 1 is used. Now, few notations. R is a notation used for? R is the notation used for inventory. Just recall. R is for demand. Yes. Then C2 is a notation used for C2. What is C2? What do you mean by C2? C2 is shortage. Okay. Then we have C1 and C3. Now, most of the students will have confusion in C1 and C3. What is C3? What is C3? What is C3? C3 is the setup cost or replenishment cost. Okay. Now, is C3 independent of time? Is the setup cost independent of time? Is it independent of time? Is it for an year, for week, for some days, or for some months? Setup cost. Is it independent of time? C3. Yes or no? Yes, dear students. Now C3 is independent of time. It is for one setup or for one procurement or for one replenishment. Okay. C3 will be independent of time, whereas C1, C2, demand, these are dependent on time. So whenever you read a question, the very first step is to decide, identify whether the given data is for model 1 or model 2. If shortages are given, it is model 2. Otherwise, it is model 1. In this case, it is for model 1. Now, once we identify the models, we write the given value. So in this case, demand is given R, that is 4,000 units. Annual they have given. So it is per year. For an year it is. Now, one more point to be noted here is all the time points specified, it should be same or uniform. Okay. Now, it cannot be one of the value is mentioned as year and the other is given in month. So what you have to do is you have to convert and make the time points uniform. All the time points mentioned should be uniform. Okay, so demand is the annual demand per year. Capital cost is 8 per unit. Inventory carrying cost is 15%. Setup cost is 150. Now, as I told you, there is always confusion with C1 and C3. Now, C3 is a value. C3 is a cost which is independent of time. So, time points will not be specified per day, per month, per year, or per week will not be specified. Okay. Whereas for C1, C1 is dependent on time. Now, is there any cost which is independent of time? Is there any cost which is independent of time? We can see here, setup cost rupees 150. Okay. Yes. So setup cost is given. So C3 is given as 150. So identify that C3 first. Once you identify the demand, write R. Next, check whether shortage is given. Write C2. Shortage is C2, penalty or inability, stock out. If all those words are there, associated with those words, if any cost is given, the amount is given, then that is taken as C2. Then identify C3. Search for a value or cost which is independent of time. It will be C3. Now the remaining cost has to be C1 because there is no C2 here. But in this case, if you see, there is a percentage value given. So whenever a percentage value is given, your C1 will be P into I. Okay, C1 will be P into I, where I is a percentage value. Now, in this case, they are saying inventory carrying cost is 15% of the capital cost. So, it is 15% of the capital cost. What is capital cost given? Capital cost is rupees 8. Capital cost is rupees 8. So, in this case, C1 will be P into I. So, I is 15%. I is 15% of the capital cost. P is the capital cost. So 8 into 15%. What is the value? 8 into 15%. So 1.2. So C1 is 1.2. So it is model 1. We have got all the values. They are asking us to calculate economic order quantity Q naught, that is square root of 2C3R by C1. Substitute and find the answer. Then they are asking number of orders N naught. N naught is 1 by T naught. So to find N naught, you have to find T naught. And T naught formula is Q naught by R. So find Q naught. Once you get Q naught, find T naught, the reordered time. Substitute and find. Once you get that, find the N naught, that is number of orders. So T naught is per year. N naught will be for so many years. Okay. Yes. So that is an inventory sum. I have taken few sums here from inventory. You just tell me whether it is for model 1 or model 2. Okay, yes. I hope it is clear. The questions are clear. Is it clear? Can you provide important statistics? The theory part, yes. I have a PDF for 1 and 2 marks. Okay. I don't know whether you have this. Do you have this PDF? Who is that? Neha. Yes. Neha, do you have this PDF for 1 and 2 marks? Along with the MCQs. Neha, are you there? Okay, you can just go through the theory part from this PDF, and also all the questions that is given after each chapter. Go through all the questions for 1 and 2 marks. Okay? Neha. Are you there, Neha? Yes, okay. Shall we continue? Shall we continue our discussion of inventory theory? Yes, dear students. Yes, okay. We shall continue. Okay, read the question. There is a demand for 800 items per year. Replenishment cost is rupees 100. Maintenance cost is 2 per item per year. Replenishment is instantaneous. Shortages are not allowed. Find EOQ and minimum average cost. Is it model 1 or model 2? Whether shortages are given? Is there any information? Yes. So it is model 1. No shortages. Model 1 is used. What is the demand? What is the demand? What is the demand? Demand is for 800 units per year. Per year. Okay. So we need C1 and C3. There is no C2 shortage cost. Now what is C3? A cost which is independent of the time point. Is there any cost where time point is not mentioned? Yes. So that is 100. So it is rupees 100. There is no time point. Per year, per month, per week is not specified. So that is C3. So remaining cost has to be C1. There is no percentage value. If there is a percentage value, C1 will be P into I. In this case, C1 will be 2. That is mentioned in terms of year. So C1 will be 2. So they are asking you to find EOQ, Q naught, the same formula, 2C3R by C1. Substitute and find. Minimum cost. So C of Q naught, minimum cost is square root of 2C1, C3R. Can substitute all the values, find the answer. Okay, the next question. Annual demand for an item is 3,000 units. Capital cost is 7. Carrying cost is 20%. Setup cost is 150. Find EOQ, number of orders and reorder time. Model 1 or model 2? What is it? Model 1 or model 2? Yes, model 1. Model 1, no shortages. So what is the demand R? Demand 3,000. Annual demand is 3,000 per year. Is there a percentage value given to you? Is there a percentage value given? Yes. So C1 will be P into I. I is the percentage value. So 20% of the capital cost. So what is the capital cost given? 7. So 7 into 20%. So 7 into 20% will be 1.4. The remaining cost has to be C3. C3 is 150. Okay, economic order quantity, it's the same formula. Then number of orders will be N naught, which is 1 by T naught. A reorder time T naught, which is Q naught by R. Q naught is the economic order quantity. Next question. The demand for an item is at the rate of 5 units per month. Inventory, there is an inventory in which the setup cost is rupees 800 per production run. Holding cost is 10. Shortage cost is 12 per unit per year. So shortage cost is given. Then it should be model 2. Model 2. So demand. What is the demand given? What is the demand? What is the demand? Yes? What is the demand? Demand is 5 units per month. As I told you, the time point should be same. The shortage cost is for a year, and even the holding cost is for a year, but the demand is given in terms of month. So annual demand. So 5 into 12, that will be 60. Okay, so C2 is given to you, shortage 12 per month, 12 units per unit per month. C3, a cost which is independent of time. Which is that cost? What is C3? A cost which is independent of time. What is C3? Yes? What is C3? Then we have C1. C3 will be 1800 per production run. The remaining cost C1 will be rupees 10. Okay, per year. Sorry, 12 per year. So it is model 2, optimal lot size, ELS, which is Q naught. So it is 2C3R by C1 into C1 plus C2 by C2. This is your formula for model 2 to find the economic lot size or economic order quantity. Substitute, take square root and find the answer. Multiply and find the answer. Maximum shortage level. So maximum shortage level is, what is the formula? Maximum shortage level, Q naught minus S naught. Maximum shortage level. And what is S naught? Minimum inventory level. So C2 Q naught by C1 plus C2. So use these connected formulas and find the required answers, maximum shortage level and optimum lot size. I hope it is clear how to identify the cost and how to identify the models. Is that clear? Inventory theory. Yes? Okay. So is there any other doubts? Any other topic that you want me to discuss? Okay. So we discussed question number 35 and 36 from the model paper. Okay, and then question number 40, that is from LPP. Okay, question number 40 will be from LPP. Yes, question number 40 is from LPP. Moving on to section D. Moving on to section D. As I told you, 3 questions will be given to you, out of which you have to answer any 2. So first question is from vital statistics. Second question will be from index number. And the third question will be from time series. Okay. So it could be 2 sub-questions under 43. It could be to find the moving averages 4 yearly, 3 yearly or 5 yearly, and to fit a linear trend, y is equal to a plus bx. Or it could be to fit an exponential trend. AB to the power x. Okay, or it could be one full question for 10 marks, that is to fit a parabolic trend. That is question number 43. Question number 42, it's already told to you. Either it could be to calculate Fisher's index number, verify FRT, TRT. It could be Marshall-Edgeworth's index number, verify TRT. Whenever Marshall-Edgeworth's index numbers, we have to verify TRT for Marshall-Edgeworth, and to compute the index number, check whether quantities are given or values are given. If suppose values or expenditures are given, then you have to find the quantities Q0 and Q1. Okay. Or it could be to find any of the 3 or 2 index numbers, maybe quantity or price index number. Be very careful. Question number 42. Okay. Question number 42, they may ask us to calculate quantity index numbers also. Okay. Question number 41. It could be STDR, NRR, GRR, or NRR, GRR, or it could be 2 5-mark question. Okay, as in this case, compute net reproduction rate and standardized death rate, or it could be compute total fertility rate and standardized death rate. Okay, so section D, you have to answer any 2 out of the 3. So I think we have discussed almost all the questions here. So section A is MCQs, that is 1 mark. So there is choose the correct answer, fill in the blanks, match the following, and Roman number 4. So Roman number 4, you should be thorough with the 1 mark question of the chapters. Okay. Most of the time, students lose marks here, the 100 scorers. So study the 1 mark question from chapter 1, then time series. Then, as I told you, one question will be from inference. And most of the time, one of the question will be from either T distribution or chi-square distribution. It could be related to, so it could be related to mean, median, mode, variance, standard deviation of T distribution or chi-square distribution. It could be binomial, Poisson, normal, standard normal. But most of the times it is T and chi-square that is asked. Okay. That is question number 18. Question number 18. T or chi-square. Question number 19. Again from inference, the theory chapter. What is parameter? What is statistic? What do you mean by parameter space? Alternative hypothesis in this case, null hypothesis, critical region, critical value, estimator, estimation, the theory concept, statistical inference. Okay. The last question will be from OR. It could be from game theory, LPP, could be from transportation theory, could be from replacement theory. It could be from any of the 5 chapters. Last question. So be thorough with question number 16, 17, 18, and 19. 1 mark questions from these chapters. Vital statistics, time series, theoretical distribution, that is T and chi-square, then inference, and then OR. Okay. Section B, it's already discussed. Section B. Okay, 2 marks. Out of 8, you should answer any 5. Any 5. So first question is from time series. Second question is from interpolation, extrapolation. You have to answer any 5. Third and fourth will be from theoretical. 25th question and 26th is from inference. 27th is from SQC. One question will be from SQC. The last question is again from OR. It could be a theory or it could be a small problem. In this case, it is to find annual average cost. Okay, so you have to answer any 5. Okay. So this is your model paper, and make strategies and try to score full in the subject, that is 80 out of 80. Is there any doubts? Yes, dear students, I hope I have completed all the concepts. Yes? May I know how was the session? Can we solve question number 38? Goodness of it once. Yes. Question number 38. 1 second. Question number 38. Okay. Yes. So question number 38. Mayur. 70 accidents that have occurred in a state in a week are tabulated as follows. Days and number of accidents. Test whether accidents occur uniformly throughout the week. Okay. Test whether accidents occur uniformly throughout the week. Now, if you see, Mayur, some observations are given to you. Data is related to accidents in a week. So you are testing the observations given to you. The frequency is given. So we are not testing for mean, neither the mean nor the variance, or nor the data is given as before and after, or in a 2 by 2 table. So it is goodness of it, as you told. Now our formula is chi-square is equal to summation y minus ei whole square divided by ei. And what is the degrees of freedom, Mayur? Whenever it is goodness of it, it is. Yes, Mayur, what is the goodness of, what is the degrees of freedom? It is n minus c degrees of freedom. Okay, n minus c degrees of freedom. OIs are given to you. OIs are given to you. Observed frequencies, that is 7, 8, 11 accidents, 12 on Wednesday, 5 Thursday, 13 and 14. Okay. Now, in order to apply the goodness of fit test, we need the EIs. EIs are the expected or the theoretical frequencies. Now, in this case, we cannot assume any distribution. Okay. We have studied two distributions, fitting binomial and Poisson distribution here. Binomial distribution, the range starts from 0 up till n. Poisson distribution, it is 0, 1 to infinity. There is no upper limit. In this case, the data is regarding accidents. Number of accidents observed day-wise. Okay. So we cannot consider it as a binomial distribution nor the Poisson distribution. So EIs, whenever frequencies are given to you, EIs are calculated using the formula. It's a proportion, population size to the sample size. So what is the population size given to you? How many accidents altogether, Mayur? 70 accidents. So what is 70 divided by the sample size? How many days? 7. So what is 70 by 7? It is 10. So EIs will be taken as 10. Okay, EIs will be taken as 10. Now, according to this test statistics, we need the difference y minus EI whole square, that is a numerator. Okay, find the difference. 7 minus 10 is 3, 3 square is 9, 8 minus 10 is 2, 2 square is 4. So find all the differences. Okay, we want sum of OI minus EI whole square by EI. Then find OI minus EI whole square divided by EI value. Okay, so divide y minus ei whole square by ei. Okay, 9 by 10, 4 by 10. So calculate all the values. Find the sum. That will be the test statistic value. Chi-square is equals to. Okay, chi-square. What will be your H naught? What will be H naught, Mayur, in that case? H naught will be accidents occur uniformly throughout the week. Uniformly throughout the week. H1 will be accidents do not occur uniformly throughout the week. We write the test statistics, summation y minus ei whole square by ei. And this follows chi-square with n minus c degrees of freedom. And what is the answer? You'll get some answer from the table. Degrees of freedom will be, okay, answer is 6.8. Okay, 6.8. Degrees of freedom is n minus c. N will be the number of values in the chi-square distribution, that is in the last column. Okay, oi minus ei whole square by ei. In that column, how many observations are there? And there is one more condition here, Mayur, ei should be 5 or more. Okay, so if any value is less than 5, you have to go for pooling. Okay, and then count the number of observations in the last column. That will be our n. N will be the number of observations for chi-square distribution. In that case, our n will be 7, isn't it? Mayur, what is n? All the EIs are 10. We don't go for pooling. So 7 observations. C is a number of constraints or conditions. Okay. Now, usually C will be taken as 1. That is for the condition that sum of OI is equal to sum of EI, which has to be satisfied always, which will be satisfied. Sum of observed frequencies will be equal to sum of expected frequency. But if suppose any parameter is estimated, if suppose we assume any distribution for the given data, and if the parameter is estimated, C will take one more value. Okay, for that parameter estimated. Now, in this case, did we assume any distribution for the given data? Did we assume any distribution? Yes? Mayur. We did not assume any distribution. Okay, there was no parameter that we have estimated. So C will be 1. C will be taken as 1. So 6 degrees of freedom. Now for 6 degrees of freedom, the test is always upper tailed. Test is always upper tailed. Okay. Alpha is not given, so we take it as 5%. So for 6 degrees of freedom, 5% upper tailed. Read the table value and conclude the test, whether we accept or reject H0. Okay. Is there any doubt? Mayur, I hope your doubt is cleared. Mayur? Are you there, Mayur? Yes? Okay. So shall we wind up the session? I hope the session was useful to you and hope the question paper will be easy and you all score 80 out of 80 in the paper. Okay? Yes. Take care and all the best for your board exams. Thank you.